All right, welcome to part 2. I hope you've looked at a video where you saw some posters, and we will review a bit of that. This is meant to just make sure there was not a whole lot of room for me to write when I had the posters up on a single whiteboard, so I just wanted to kind of go through just to rehash some of the stuff. There'll be some new stuff at the very end of this and just some additional warnings, things and reminders and so on. But one of the first things that was asked was, what is your guess of f of 4? And the guess of f of 4 was 3. We don't want to write f of 4 equals 3 because maybe that's not true, right? There was a ribbon hiding in the way, and what you end up writing is this. So you write the limit of f of x as x approaches 4 equals 3. So this is how you say it. That was in fact the text that I just said. You do need to write all the pieces, so it would be considered incorrect to just write f of x equals 3. Where's the limit? You could write lim f of x equals 3, but there's still something missing here. We've got to be specific about what x is approaching. That is the word that gets used here, right? The idea is if a ribbon is down, if a piece of dental floss is down, hiding what's happening where x equals 4, what would be the guess? And then we revealed under the ribbon and saw that f of 4 actually was 3. On the second poster, we had a function called g, and g of 6 happened to equal 4. But what was the guess for g of 4? That is, when x is 4, what is the guess for the y value? And we guessed that g of 4 was equal to 3. And that's the information, that's all the information we needed. Even with the ribbon down, hiding what's going on, we could write that the limit of g of x as x approaches 4 is equal to 3. That's fine. Just because this is the second example we're looking at, just a different kind of warning to mention is that it would be incorrect to write this. Notice the difference between these two is that there's an x here, there's a 4 there. So writing a 4 here is considered incorrect. Then we revealed under the ribbon and saw that g of 4 was actually equal to 1. And just to kind of reemphasize, it's easier to reemphasize here than it was with limited space on the board earlier, but even though g of 4 is actually 1, our guess for g of 4 when covering x equals 4 with a vertical ribbon, our guess for the y value was 3. So writing this is correct, right? So g of 4 equals 1, so writing this is correct. Writing limit of g of x as x approaches 4 equals 3 is correct. Emphasis on the fact that there is this limit of g of x as x approaches 4. The takeaway message, right, the key thing to think about here is that the value of the limit of g of x as x approaches 4 did not depend at all on the actual value, did not depend on g of 4 at all. That's why there was a ribbon hiding, and we could answer the question even when the ribbon was in place. On the third poster, there was a third function. On this third poster, the limit, again, the guess of the y value is equal to 3. Take a look at all the pieces of the notation. This all matters. So the limit of h of x as x approaches 4 was equal to 3, even though h of 4 does not exist. Right? So just like earlier, how the limit for g as x approaches 4 did not depend on the value of g of 4 at all, similarly the limit of h of x as x approaches 4 also did not depend on the value of h of 4. In fact, h of 4 did not exist. And to summarize, we have this information. So these were the limits, right? In each case, the limit was 3. These are the actual values. We had 3, which matched. We had 1, which did not match. And we had does not exist. It's not even a number, right? So over here, these are the new things. These are the calculus problems. This is the guess of the y value as x gets close to 4. And these are the actual y values when x is equal to 4. And to find the actual values, we had to look under the ribbon. And for the guess, we did not have to look under the ribbon at all. The notation absolutely matters. It absolutely, absolutely, absolutely matters here. And so I would just like to mention that in terms of how the notation works, and you hear this phrase a lot, is that the limit of a function is a number. So you see a limit of a function equals a number, and that number is L here. So, these are sort of cartoon versions of the same. Here we have the situation where if you were to hide what's happening here, right along here vertically with a vertical ribbon, your guess for the y value would be the same as the actual y value. And if you hide here, your guess for the y value would be different than the actual y value. And here, your guess for the y value would be different than the actual y value, in that your guess would be this y value, whatever the height is, but the actual y value, well, we don't have one in this case. And again, I want to reemphasize that the value of the limit of f of x as x approaches a certain number, let's call it c, and the last example is 4. The limit of f of x as x approaches c does not depend on the value of f of c, and in fact, f of c might not even exist, as we see in this example here, or specifically as we saw in this example right there. Let's take a look at another example, different kind of example. So let's take a look at the function f of x equals absolute value of x. And for this function, what is the limit of f of x as x approaches 0? So what we should do is, as we've done to find limits elsewhere, well, we should go off of a picture. There's ways to do this without a picture we'll look at later. But here's a graph of the absolute value function right there, this v shape. And now that we have drawn this, to answer the limit question, even though we know the full picture, we should just do the same thing, right? We should hide what's going on with a vertical ribbon right here when x is 0. So we hide this, basically cover the y-axis with a vertical ribbon, and then we should guess what the y value is. And take a look at just this part and this part. As we zoom in here, we see that the guess for the y value ought to be 0. And so there it is, right? So the guess of the y value is right here. This 0 is talking about as x, as we move in with x being closer to 0. So the limit of f of x as x approaches 0 for this function is the number 0. And again, here's the mantra again, the limit of a function, that part's the function, is, that's the equal sign, is a number, and the number here is 0. This is a good time to take a look at a worksheet that is available. It looks like this. You can find a PDF of this online. Here's the graph of a function. Now, to take a look at the limit, so let's look at the x value of -8. So where is that? There's -5, -6, -7, -8. So take a look right here. And now, even though we see the whole thing, you know, imagine, hide what's going on along this vertical line with a ribbon, with a piece of dental floss, right? And so let us guess what the limit is going to be. So this is a generic notation, but I replaced the c with a -8 right here. So what would be our guess for the limit of this function as x approaches -8? If we were to cover what's going on here, I would say that the guess is 2. And so we'll say exists, check that box, and put a 2 right here. And then what about f of -8? So that requires looking by revealing what our ribbon is hiding. Here we actually get to look, and that's this point right there. I believe the y coordinate there is 10. So we'll say exists, check exists, and f of -8 is equal to 10. Go ahead and download, freeze your screen for a moment, take a screenshot of this. There is a PDF posted. It would be helpful to look at that, but if you want, you do a screenshot. I'm going to scroll down, and there's some additional questions to answer right here. So I would suggest you pause the video at this point, try these yourself, and then I would like to walk through them right after that. Okay, I hope you did pause, I hope, and now if you're back, welcome back to the video, and let's take a look at what happens near -5. So you cover, let me scroll back up here, sorry to do this, but you cover this right here with a vertical line, and the limit exists is +5. So I would say we check this box right there and say the limit of f of x as approaches -5 is +5. What about the actual y value? Yeah, that exists, and the actual y value is 2. So I'd check this box here and say f of -5 equals 2. Now all this is written in here so to get you used to the notation. And then what about when the next x value we'll look at is -3? Again, cover with a vertical ribbon. And if this is covered right here with a vertical ribbon, I would guess that the y value is 1. And so we'll say that for the limit, this third limit problem here, we'll check this box for exists and say that the limit is 1. However, if we reveal under the ribbon, there is no actual y value. There's no filled in dot. Right, that's an unfilled dot there. And so we'll check the box here that says f of -3 does not exist. At -1, if we were to hide what's going on right at -1 with a ribbon, then our guess for the y value would be 3. And if we reveal under the ribbon, the actual y value is also this point right there, is 3. So I'd say here we check this box and write 3, and check this box and write 3. And then if we look at the x value of 1 next, that's right along here, hide with a ribbon. The guess of the y value is 4. And we reveal under the ribbon, the actual y value is -5. So check that box, put a 4 there, check that box, put a -5 here. When x is 4, let's take a look right along here. Okay, hide that with a ribbon. There's a curvy shape here, but the guess for the y value would be 1, and if you reveal under the ribbon, it looks like the actual y value is 1. So check 1, check, and 1 right there. When x is 5, so we hide there with a vertical ribbon to guess the y value, and the guess of the y value, also called the limit. The limit is 5, and the actual y value, well, does not exist. So scroll down here. We would check that the limit exists and is 5, so the limit of f of x as x approaches 5 equals 5. But f of 5 does not exist, so you check that box right there. And finally, we'll look at 8. So when x is 8, we cover what's going on here with the ribbon. Yep. And the guess of the y value, if we were to cover this with a ribbon, we wouldn't see that dot there at all, right? So the guess of the y value would be -2, and then reveal under the ribbon the actual y value is 1. So here, check exists, limit is -2, and then f of 8 exists and it's another number. I already forget. It's not -2. Let me scroll back up here. It is the number +1, so that's the number that we'd write right